Hi, hello dear students. Welcome to physics class PU2. We have been discussing about the chapter real nature of radiation and matter. So in the previous class, we have discussed about the introduction part of the chapter. That is, we have discussed about what is an electron emission. The process of emission of electron from the metal surface is called as what? The electron emission, that we have defined, and the three different types of electron emission we have discussed, that is the thermoionic emission, then photoelectric emission, and the field emission. So you all know that what is meant by work function, right? So the minimum amount of energy required to liberate the electrons from the metal surface, that is called as the work function. Now, based on the type of energy we are going to supply to liberate the electrons, based on that we are given three classifications, that is thermoionic emission, photoelectric emission, and one more is field emission. Right? Now, particularly we are going to discuss here about the photoelectric emission, that is the photoelectric effect. The phenomenon of photoelectric effect discovered by Heinrich Hertz in the year 1887. Right? What is photoelectric effect? The phenomenon of emission of electrons from the metal surface when a light radiation of suitable frequency is incident on the metal surface. That phenomenon is called as the photoelectric effect. And the liberated electrons are called as what? The photoelectrons. And the current thus obtained from the photoelectrons is called as photocurrent or photoelectric current. Now, in this class, I am going to discuss here about the experimental results of photoelectric effect. So, Heinrich Hertz studied the phenomenon of photoelectric effect by experimental study. Now, we are going to discuss here the experimental study of Heinrich Hertz. Now, let us discuss here first the experimental arrangement of the photoelectric effect studied by the Heinrich Hertz. Then we will discuss what are the experimental results obtained from the experiment, right? Then those are called as what? The laws of photoelectric effect. Those results are called as what? The laws of photoelectric effect. Now let us see here the experimental arrangement of the photoelectric effect, that is the study of photoelectric effect. So here the experimental arrangement consists of what? The first one, T. So here T means what here? It consists of a evacuated glass tube, T. The experimental arrangement consists of what? The evacuated glass tube, T, which is fitted with a coach window. Sidewise it is fitted with what? A coach window to illuminate the light radiation. It is denoted by the symbol W. Again, this glass tube is enclosed by a photosensitive material which acts as the cathode. So here C means what? Which is a photosensitive material which is used as a cathode, photosensitive material which acts as a cathode. Also it acts as a what? Emitter, right? Which emits the electrons. Again, anode plate. Again, this evacuated glass tube enclosed by what? A cathode, which acts as a photosensitive material, and again it is enclosed by anode. And these two, cathode and anode, are connected to a what? High tension DC battery, right? To maintain the potential difference, a high tension battery is connected. Variable high tension battery is connected to maintain the potential difference between the cathode and anode. Again, here key is connected and a microammeter is connected. What is ammeter? Ammeter is a device which is used to measure the current. So here we are using a microammeter to measure the current obtained by the photoelectrons. So here what happens? This is the experimental arrangement. Now, what is photoelectric effect? When a light radiation of suitable frequency, is incident on the photosensitive material cathode, the photoelectrons are emitted, right? So these emitted photoelectrons are attracted towards the anode, right? This attracted towards the anode, and hence you will get a photoelectric current here, right? So when a radiation of suitable frequency incident on the cathode, these electrons are emitted, and the emitted electrons are attracted towards the anode A, which is maintained at a positive. This anode is positive because this is positive and this is negative. Anode is maintained at a positive potential with respect to cathode, that is the emitter. So electrons are attracted towards the what? The anode, right? So in this way, finally, what we will get? The flow of emitted electrons. Due to the flow of these emitted electrons, we will get the photoelectric current, right? Due to the flow of emitted photoelectrons, the current is obtained. That can be measured here from the microammeter. And the current thus obtained, that is called as what? The photocurrent. Current thus obtained is called as what? The photocurrent, or it is also called as what? The photoelectric current. It is also called as what? The photoelectric current or photocurrent. Now, so we have studied here the experimental arrangement and how the photoelectric effect phenomenon takes place and how we are getting the photocurrent. Now we have to study here the experimental result, that is in laws of photoelectric effect, how the photocurrent is depends on intensity of incident radiation. So we have to study here in case of experimental results. First one, how the photoelectric current is depends on intensity of incident radiation. We have to discuss here what? The first one, how it is depends on intensity of incident radiation, and second one, frequency of incident radiation. So first one, how it is depends on intensity of incident radiation, how it is depends on frequency of incident radiation, and also the potential difference between the electrodes, potential difference of the voltage applied between the two electrodes, and again one more, the nature of photosensitive material. Nature of photosensitive material. So the experimental arrangement is very simple, which consists of what? The evacuated glass tube, side by side, it is fitted with a quartz window to eliminate the radiation, light radiation. Again, the glass tube is fitted with what? Enclosed by cathode, which acts as a photosensitive material, which emits the electron, and again it is enclosed with what? The anode. Right, this cathode is connected to a high tension battery, which is used to maintain the potential difference between the cathode and anode. Again, key is used here, right, for switch off and switch on, and again the micrometer is used to measure the photocurrent, right. And this anode is made positive with respect to cathode, and cathode is acts as a negative. So cathode is at negative potential and anode is at positive potential. Right? When a light radiation of suitable frequency is incident on the photosensitive material, the photoelectrons are emitted. Those emitted photoelectrons are attracted towards the anode, and due to the flow of these photoelectrons, we are getting here the photocurrent or photoelectric current. Now we are going to discuss here in the case of experimental results of the laws of photoelectric effect, how this photoelectric current is depends on the intensity of incident radiation. Light radiation incident on what? The cathode. Light radiation cathode photoelectrons emit anode kade move hogodrinda namage ಏನು ಸಿಗುತ್ತೆ photoelectric current ಬರ್ತದೆ. But ಈ photoelectric current intensity ಮೇಲೆ ಯಾವ ರೀತಿ ಡಿಪೆಂಡ್ ಆಗಿದ್ದಾರೆ? Light radiation intensity ಮೇಲೆ ಯಾವ ರೀತಿ ಡಿಪೆಂಡ್ ಆಗಿದೆ? Frequency of incident radiation ಮೇಲೆ ಯಾವ ರೀತಿ ಡಿಪೆಂಡ್ ಆಗಿದೆ? Again, the potential difference, ಈ voltage ಮೇಲೆ ಯಾವ ರೀತಿಯಾಗಿ ಅಪ್ಲೈ ಮಾಡಿದಂತ voltage ಮೇಲೆ ಯಾವ ರೀತಿ ಡಿಪೆಂಡ್ ಅದ, and finally ಇದು photosensitive material, ಅದು material nature ಮೇಲೆ ಕೂಡ ಡಿಪೆಂಡ್ ಇದೆ. So in this way, now let us discuss here the experimental results of photoelectric effect, how it is depends on the intensity of incident radiation, frequency of incident radiation, and how it is depends on the potential difference between the two electrodes, and one more is the nature of photosensitive material. Okay, now let us discuss here the experimental results of this photoelectric effect, the study of photoelectric effect. Those are also called as the laws of photoelectric effect here. Let us discuss the experimental results one by one. So it is an important question for 5 mark or 3 mark. Write any 3 experimental results of photoelectric effect for 3 mark, and for 5 mark you have to write 5 experimental results. Those are also called as what? The laws of photoelectric effect. So first one, the photoelectric effect is instantaneous process. The photoelectric effect is instantaneous process. Instantaneous means what? Immediately. You know it what? Instantly or immediately or suddenly. The photoelectric effect phenomenon takes place instantaneously. That means what? As soon as the radiation falls on the cathode, the current is measured immediately. So it is called as what? The instantaneous. ಏನಾಗ್ತದೆ ರೇಡಿಯೇಷನ್ ಬಿಲ್ ಕೂಡ ನಮಗೆ ಏನಾಗ್ತದೆ ಕರೆಂಟ್ ಮೆಜರ್ಮೆಂಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ಇಟ್ ಈಸ್ ಇನ್ಸ್ಟಂಟ್ ಆಗಿ ಏನಾಗ್ತದೆ ಆಗ್ತದೆ, and that is phenomenon is called as what? That instantaneous process. ಸಡನ್ ಆಗಿ ಏನಾಗ್ತದೆ ರೇಡಿಯೇಷನ್ ಬಿಲ್ ಕೂಡ ನಾವು ಕರೆಂಟ್ ಮೆಜರ್ ಮಾಡ್ತೀವಿ. So that is called as what? The instantaneous. The photoelectric effect is instantaneous process. That is the important concept, right? When a radiation falls on the photosensitive material, the current is measured immediately. When a radiation falls on the cathode, that is the emitter, photosensitive material, the current is measured immediately in micrometer. So that's why it is called as the instantaneous process. The photoelectric effect is instantaneous process. And second point is also very important. As you know that, what is work function? What is work function? The minimum amount of energy required to liberate the electrons from the metal surface, that is called as work function. So each radiation is having a certain frequency. So you know that the energy is equal to h nu, that is based on Planck's quantum theory of radiation. We are going to explain here. So energy and frequency mu, where h is Planck's quantum. So as the frequency of incident radiation goes on increases, the energy also goes on increases. Energy increases. So for a minimum frequency, right? Minimum frequency, minimum energy. For a given photosensitive material, photo emission takes place above a certain minimum frequency. ಎಲ್ಲ ಯಾವುದೇ ಫ್ರೀಕ್ವೆನ್ಸಿ ಬಿದ್ದರೂ ಇಲ್ಲಿ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಮಿಟ್ ಆಗಿ ಬರಂಗಿಲ್ಲ. ಸರ್ಟನ್ ಮಿನಿಮಮ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರ್ತದೆ, ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಏನಾಗಬೇಕ್ರಿ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರುವಂಥ ರೇಡಿಯೇಷನ್ ಇದ್ರ ಮೇಲೆ ಆಗಬೇಕು ಇನ್ಸಿಡೆಂಟ್ ಆಗಬೇಕು, ಯಾವುದ್ರ ಮೇಲೆ ಕ್ಯಾಥೋಡ್ ಮೇಲೆ, ರೈಟ್? ನೌ ದೇರ್ ಇಸ್ ಎ ಫಾರ್ ಎ ಗಿವನ್ photosensitive material, the photoelectric effect or the emission of photoelectrons takes place above a certain minimum frequency. The minimum frequency of incident radiation, ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಫ್ರೀಕ್ವೆನ್ಸಿ ಬಿತ್ತಂದ್ರೆ ಏನಾಗ್ತೈತೆ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಂತ. ಆ ಮಿನಿಮಮ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ಇನ್ಸಿಡೆಂಟ್ ರೇಡಿಯೇಷನ್ ಕನ್ನ ಏನಂತ ಕರಿತೀವಿ ನಾವು? ದಟ್ ಮಿನಿಮಮ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ಇನ್ಸಿಡೆಂಟ್ ರೇಡಿಯೇಷನ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್? ಥ್ರೆಶೋಲ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ, or it is denoted by the symbol mu. Again the frequency, again we can write here what? The threshold wavelength, and the corresponding wavelength of that radiation, threshold wavelength, that we denote here what? The threshold wavelength. Threshold wavelength, it is denoted by the symbol lambda naught. So corresponding frequency, the minimum frequency is called as threshold frequency, and the corresponding wavelength is called as what? Threshold wavelength. Right? So you know that the frequency, energy is directly proportional to frequency and inversely proportional to wavelength, right? As the wavelength goes on increases, its energy goes on decreases. So corresponding maximum wavelength, it is minimum frequency. Maximum wavelength is the minimum frequency. So that is called as what? The threshold wavelength and threshold frequency. right? So first point we have discussed here, it is an instantaneous process, and second point is threshold frequency is required. What is threshold frequency? What is threshold frequency? The for a given photosensitive material, the photo emission takes place above a certain minimum frequency of incident radiation. That frequency is called as what? The threshold frequency. Now third one, the intensity. How the intensity of radiation is depends on photoelectric current. So intensity of incident radiation or photoelectric current is directly proportional to the intensity of incident radiation, and that is also possible above the threshold frequency. Above the threshold frequency, the photoelectric current, and for a given photosensitive material, photoelectric current is directly proportional to the intensity of incident radiation. Above the threshold frequency, photocurrent or photoelectric current, above the threshold frequency, photoelectric current is directly proportional to the intensity of incident radiation. So above the threshold frequency ಗಿಂತ ಜಾಸ್ತಿ frequency ಇರುವಂತ ರೇಡಿಯೇಷನ್ ಇನ್ಸಿಡೆಂಟ್ ಆದ್ಮೇಲೆ ಏನಾಗ್ತದೆ, ರೈಟ್? above the threshold frequency ನಾವಲ್ಲಿ ಇಂಟೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಮಾಡ್ಕೊಂತ ಹೋದ್ವಿ ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, ಲೈಟ್ ಇಂಟೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋದಾಗ ನಂಬರ್ ಆಫ್ ಫೋಟಾನ್ಸ್ ಜಾಸ್ತಿ ಇನ್ಸಿಡೆಂಟ್ ಆಗ್ತದೆ ಫೋಟೋಸೆನ್ಸಿಟಿವ್ ಮಟೀರಿಯಲ್, ಅಂದ್ರೆ ನಂಬರ್ ಆಫ್ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಮಿಟ್ ಆಗೋದು ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ. ಸೊ ಆಸ್ ಅ ರಿಸಲ್ಟ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಹಿಯರ್, the photoelectric current goes on increases. So above the threshold frequency, if we increase the intensity of incident radiation, the photoelectric current goes on increases. That means the photoelectric current is directly proportional to the intensity of incident radiation. So here we can plot the graph of intensity of incident radiation versus photoelectric current. So here we are going to take on y-axis as photocurrent and on x-axis intensity. So as the intensity goes on increases, the photoelectric current goes on increases. So direct relation, right? Direct relation between photocurrent and intensity. As the intensity of incident radiation increases above the threshold frequency, the photoelectric current also goes on increases. ಯಾಕಂದ್ರೆ ನಂಬರ್ ಆಫ್ ಇಂಟೆನ್ಸಿಟಿ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದಾಗ ನಂಬರ್ ಆಫ್ ಫೋಟಾನ್ಸ್ ಇನ್ಸಿಡೆಂಟ್ ಆಗುತ್ತೆ, ಅದ್ರ ಮೇಲೆ ಕ್ಯಾಥೋಡ್ ಮೇಲೆ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ. ಫೋಟಾನ್ಸ್ ಜಾಸ್ತಿ ಇನ್ಕ್ರೀಸ್ ಆಗೋದ್ರೆ ಏನಾಗ್ತದೆ, ಮೋರ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಮಿಟ್ ಆಗ್ತಾವೆ, ಸೊ ವಿಲ್ ಗೆಟ್ ಮೋರ್ ಕರೆಂಟ್, ರೈಟ್? ಸೊ ನೌ I think all these three results are understood. Till we have to discuss two results here, right? The photoelectric effect is first one, instantaneous process. The first one, as the radiation incident on photosensitive material, the current is measured immediately. For a given photosensitive material, the photoelectric emission takes place above a certain minimum frequency. A minimum frequency ಗಿಂತ ಕೆಳಗಿತ್ತಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಮಿಟ್ ಆಗಂಗಿಲ್ಲ. That frequency is called as what? The threshold frequency. And the corresponding wavelength is called as what? Threshold wavelength. Maximum wavelength ಅಂತದ minimum frequency. Maximum wavelength ಗಿಂತ ಮತ್ತೆ wavelength ಜಾಸ್ತಿ ಆಯ್ತಂದ್ರೆ ಏನಾಗ್ತದೆ, ಅವಾಗ ಎನರ್ಜಿ ಕಡಿಮೆ ಆಗ್ತದೆ, right? As the wavelength increases, the energy as the wavelength decreases, energy increases. So next, third one, above the threshold frequency, the photoelectric current is directly proportional to what? Intensity of incident radiation. Intensity of incident radiation increase ಮಾಡಿದಾಗ the photo current goes on increases. So photoelectric current goes on increases if we increase the intensity of incident radiation. Now let us discuss here the two more results. So next, the fourth result of experimental study of photoelectric effect. So as we have discussed here, the three important results. One is the instantaneous process, second one is the threshold frequency, and third one is the intensity of incident radiation. As the intensity of incident radiation increases, the photoelectric current increases. And the fourth one is related to what? The kinetic energy of the photoelectrons, and how it is related to the frequency of incident radiation. So you know, as the radiation of suitable frequency, that is threshold frequency, is incident on the cathode, the photoelectrons are emitted because they are moving towards the anode with certain kinetic energy. Kinetic energy with velocity, right? With certain velocity, with certain kinetic energy, they move towards the anode plate, right? Because here anode is kept at a positive potential with respect to cathode. Right now, these electrons are moving towards the anode. So, out of the kinetic energy of these photoelectrons, how it is depends on the frequency of incident radiation. Right? If frequency of incident radiation increase ಮಾಡಿದಾಗ kinetic energy of the photoelectrons ಏನಾಗ್ತದೆ ಅನ್ನೋದು fourth result of ನೋಡೋಣ. So, above the threshold frequency ಗಿಂತ ಮತ್ತೆ ಜಾಸ್ತಿ frequency of incident radiation ಕೊಟ್ಟಾಗ ಏನಾಗ್ತದೆ, the kinetic energy of the photoelectrons goes on increases with increase in the frequency of incident radiation. ಅಂದ್ರೆ frequency of incident radiation ನಾವು increase ಮಾಡ್ತಾ ಹೋದ್ವಿ ಅಂತಂದ್ರೆ ಏನಾಗ್ತದೆ, the kinetic energy of the photoelectron also goes on increases, right? And the kinetic energy of the photoelectrons is independent of intensity of incident radiation. Intensity of incident radiation increase ಮಾಡಿದ್ವಿ ಅಂತಂದ್ರೆ ಏನಾಗ್ತದೆ, only current increases. Only the photoelectric current increases if we increase the intensity of incident radiation, but the kinetic energy of the photoelectrons remains the same. But if we increase the frequency of the incident radiation, then the kinetic energy of the photoelectrons also goes on increases. This is the fourth result that is shown here in the graph. Right? Here, as the frequency of incident radiation increases, the kinetic energy of the photoelectrons increases. So this is what the fourth result. So first one, instantaneous process. Second, threshold frequency is required. Then third one, the photocurrent is directly proportional to intensity of incident radiation. And fourth one, the kinetic energy of the photoelectrons is directly proportional to what? The frequency of incident radiation. Now, the fifth result we are going to discuss about the stopping potential, right? Regarding the stopping potential. Now, what is the stopping potential? Fifth result, the photoelectric current becomes zero. The photoelectric current becomes zero at a particular negative voltage, and that negative voltage is called as what? The stopping potential. This stopping potential, it is also called as what? Retarding potential. Stopping potential is also called as what? The retarding potential. So what is meant by stopping potential or retarding potential? So to know about the what is the stopping potential or retarding potential, again we have to go to study the experimental diagram. So now we can see what is meant by stopping potential or retarding potential. If the anode plate is made negative, if the anode plate is made negative with respect to cathode, that is cathode is made positive. So ಇದನ್ನ ನೆಗೆಟಿವ್ ಮಾಡಿದ್ವಿ ಅಂತಂದ್ರೆ ಏನು ಮಾಡ್ತೀವಿ, ಈ ಬ್ಯಾಟರಿ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ವಿ ನಾವು, ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್ is connected to what? Anode. So when the anode plate is kept at the negative potential, really negative potential ಇರೋದ್ರಿಂದ electrons also what? The negatively charged particles. Electrons ಅನ್ನು ಏನಾದವ್ರಿ negatively charged particles. ಇದನ್ನು anode ಅನ್ನು ಏನು ಮಾಡಿದ್ವಿ ನಾವೀಗ ನೆಗೆಟಿವ್ ಮಾಡಿದ್ವಿ. So the electrons, they do not move towards the anode. They retarded ಅಂದ್ರೆ ಏನ್ರಿ, ಅವರ velocity decrease ಆಗ್ತಾ ಬರ್ತದೆ. Right? If we increase the negative potential of the battery, right, negative potential ಅನ್ನು increase ಮಾಡ್ತಾ ಹೋದ್ವಿ ಅಂತಂದ್ರೆ, ಇದು negative potential ಅನ್ನು increase ಮಾಡ್ತಾ ಹೋದ್ವಿ ಅಂತಂದ್ರೆ ಏನಾಗ್ತದೆ, at a certain potential, at a certain potential, the the flow of electrons towards the anode stops, or the reach of electrons towards the anode stops. But ಇಲ್ಲಿ current sudden ಆಗಿ zero ಆಗಲಿಲ್ಲ. The photoelectric current suddenly will not become zero suddenly. Sudden ಆಗಿ current ಏನಾಗಲಿಲ್ಲ, zero ಆಗಲಿಲ್ಲ. That indicates what? The electrons have a certain kinetic energy. ಯಾವ ರೀತಿ ನಾವು ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ, so in the same way what happens here, the slowly the reach of electrons towards the anode decreases, and finally the flow of electrons stops. Right? That means what? The negative potential or the stopping potential means what? The minimum negative potential of the anode for which the no electrons reach the anode. ಇಲ್ಲಿ ಎಷ್ಟು ಪೊಟೆನ್ಷಿಯಲ್, ಯಾವ ವೋಲ್ಟೇಜ್ ನೆಗೆಟಿವ್ ವೋಲ್ಟೇಜ್ ಯಾವ ನೆಗೆಟಿವ್ ವೋಲ್ಟೇಜ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆನೋಡ್ ರೀಚ್ ಆಗೋದು ಸ್ಟಾಪ್ ಆಗ್ತದೆ. ಎಲೆಕ್ಟ್ರಾನ್ಸ್ the reach of electrons towards the anode stops. That potential is called as what? The negative potential. Right? ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, certain minimum kinetic energy ಇರ್ತದೆ. Okay? So because of that minimum kinetic energy we will get the current here. As the negative potential goes on increases, at a certain potential the reach of electrons towards the anode stops, and finally the current also becomes zero. ಏನಂತ ನೋಡಿ, the photoelectric current just becomes zero. Current zero ಆಗ್ತಾ ಬರುತ್ತೆ, so only decreases as we increase the negative potential. At a certain minimum potential it becomes zero. Photoelectric current becomes zero at a particular negative voltage. That negative voltage is called as what? Stopping potential. So initially we have made it positive. ಒಂದು ಪಾಸಿಟಿವ್ ಮಾಡಿದ್ವಿ, ಇದನ್ನ ನೆಗೆಟಿವ್ ಮಾಡಿದಾಗ ಏನಾಗ್ತೈತಿ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆನೋಡ್ ರೀಚ್ ಆಗೋದು ಸ್ಟಾಪ್ ಆಗ್ತೈತಿ. ಅದು ಯಾವ ಪೊಟೆನ್ಷಿಯಲ್ಗೆ ಏನಾಗ್ತದೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ರೀಚ್ ಆಗೋದು ಸ್ಟಾಪ್ ಆಗ್ತದೆ. ಆ ಪೊಟೆನ್ಷಿಯಲ್ಗೆ ಏನಾಗ್ತದೆ, ಆ ಪೊಟೆನ್ಷಿಯಲ್ಗೆ ಏನಂತ ಕರಿತೀವಿ ನಾವು, ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್, or it is called as what? The retarding potential. ಆ ಪೊಟೆನ್ಷಿಯಲ್ಗೆ ಏನಾಗ್ತದೆ, photoelectric current ಏನಾಗ್ತದೆ, zero. Photoelectric current becomes zero at the negative potential of the anode is called as what? The stopping potential. The photoelectric current becomes zero at a particular negative voltage, and that negative voltage is called as what? The stopping potential. So with all this, the discussion of the experimental results of the laws of photoelectric effect, the 5 important results what we have discussed here. The first one is instantaneous process. The photoelectric effect is what? The instantaneous process. Second one is about the threshold frequency. The threshold frequency is required for photoelectric emission. And the third one, intensity of incident radiation is directly proportional to, the photoelectric current is directly proportional to intensity of incident radiation. And the third one related to kinetic energy of photoelectrons. The kinetic energy of photoelectrons is directly proportional to the frequency of incident radiation. And finally related to stopping potential. Right? So the photoelectric current becomes zero at a particular negative potential, and that potential or the retarding potential, why it is called as retardation? You know that retardation and acceleration. Acceleration is the velocity increase ಆಗ್ತಾ ಹೋಗ್ತದೆ. ರಿಟಾರ್ಡೇಷನ್ ಅಂದ್ರೆ ಏನ್ರಿ, ವೆಲಾಸಿಟಿ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಸೊ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಏನಾಗ್ತೈತ್ರಿ, ಇದ್ರ ವೆಲಾಸಿಟಿ ಕಡಿಮೆ ಆಗ್ತಾ ಬರ್ತೈತಿ, ಅಂದ್ರೆ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಕಡಿಮೆ ಆಗ್ತಾ ಬರ್ತೈತಿ, ಅಂಡ್ ಫೈನಲಿ ಸ್ಟಾಪ್ ಆಗ್ತದೆ. ಅವಾಗ ಏನಾಗ್ತೈತಿ, ಕರೆಂಟ್ ಝೀರೋ ಆಗ್ತದೆ. ಅದಕ್ಕೆ ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಂತ ಕರೀತೀವಿ. Photoelectric current just becomes zero at a particular negative voltage of the anode, and that is called as stopping potential or retarding potential. So this experimental study of photoelectric effect, that is studied by Heinrich Hertz, and these are the experimental results of photoelectric effect. This is a very important 5-mark question, and they must get for 3-mark also. Okay students, in the next class we will discuss about the next points related toward the dual nature of radiation and matter. We will discuss about the Planck's quantum theory of radiation and Einstein photoelectric equation. Thank you students.